Hi everybody, welcome back to Module 4. We are going to start officially our statistics, besides levels of measurement, which I know you all found terrifying. This is not going to be so bad. We are going to talk about frequency distributions today, and I will show you how to do a group frequency distribution in class because it's a little bit more involved and might take a little bit too much time. But basically, the whole purpose of frequency distribution is that it is one of the most basic types of descriptive statistics. And we have two types of statistics that we're going to learn. The first semester, 205, we're going to focus on descriptive statistics, which the purpose of descriptive statistics is to describe and simplify data to be able to present it in a way that makes sense to an audience in a more basic way. So rather than having a bunch of scores like this, or a bunch of test scores, or a bunch of IQ scores, we want to go ahead and organize them in some way that makes sense, whether we're talking about central tendency, which we'll talk about next module, or whether we're talking about making a table. Either way, we're simplifying a bunch of numbers, a bunch of names, a bunch of whatever it might be. So we're going to start talking about descriptive statistics now, and when we do that, the first thing you want to learn about is called a simple frequency distribution. These are really pretty simple. But what you want to do is you have scores, you have data over here. So for example, say these are all quiz scores. And you want to know, well, how many of each score do I have? There are a couple of things that we might want to know. Well, we might want to know how many scores we have, and that's denoted here as n equals 20. So we have 20 scores. And how do we know how many scores we have? Well, we can count them, but once we make our frequency distribution table, we want to check and make sure that that's correct. And the way that we can do that is by adding our frequencies up. So once we have created our table, when we add these numbers up, they will equal n, or 20 in this case. And I'll talk about this one in just a second, or the sum of x, which just means the total of all the scores added up together. Okay, so the first thing you do is you write down all of your scores. You look at the scores and you see what the range of scores is. We have, and you'll have to kind of take a few minutes to do this, but you'll look and you'll see that 10 is the highest number, and then you'll look through and you'll see that eventually 2 is the lowest number. There is no 1, so there's no point in going down to 1 because it is not within the range. The range of scores, or the lowest to highest, is 2 to 10. So that's what I've done here. I've started with a top number, and that's what the convention is for a frequency distribution table. You start with the top, the highest number, and go down, and you have to include every number within the range. So even though we don't have any 4s, for example, we still include 4 within the table. That way you can easily see, okay, well, there are no 4s. And so rather than presenting this information to our audience who's going to see it, they look at this and it makes a lot more sense. They can say, well, what's the most frequent score, or how many people did, this way or that way on the quiz. So first you write your scores down, and then you go through and basically just tick mark them off. Okay, so I have 10. How many 10s do I have? Well, I've got 2. So the frequency is 2. So here are my scores, and here are my frequencies. These are denoted by X, and these are denoted by F for frequency. Now, how many 9s do I have? Well, let's see, I've got 1, 2, and I like to cross them out because I might miscount otherwise, 3, 4. So I have 4 9s, etc. How many 8s do I have? I have 1, 2, 3 8s. So that's what I'm doing. I'm just basically indicating what my scores are and then counting the number of times, or the frequency in which they occur in this particular distribution of scores. And that just means a bunch of scores. Okay, how the scores are distributed. So then we go down to 7. How many 7s do we have? We have 1, 2, did I miss one? 3. 3 7s. And then how many 6s? 1, 2, 3. Notice how we have a lot of scores that have 3 of them. That's an important thing that we'll talk about a little bit later. So how many 5s do we have? 1, 2, and 3. So it makes it easier to see once you cross them out. You don't have to look at those anymore. 4s, we have no 4s, so we go ahead and put a 0 there. And we don't just skip over it, like I mentioned, we don't go 5, 3. We have to include that. If we had no 3s, we would also include a 3 and put a 0. If we had no 6s, we would put a 0. But you have to include every number within that range. So how many 3s do we have? We have 1 3. How many 2s? We have 1 2. I've written those right there. And how are we missing anything? Is there anything that hasn't been crossed out? No. So now we have each score and the number of times it appears in our distribution of scores. So this is what's called a simple frequency distribution table. It's simple because you're listing every single score, each and every one. You're not combining them and making them into groups or intervals of scores, which we'll talk about in class. But basically, this is the idea of making a table, a frequency distribution table. So now, if you wanted to find out the total n, let's make sure that we got it right. We add 2 and 4 and 3 and 3 and 3 and 3 and 1 and 1. That should equal 20, because the sum of the frequencies, or the column of frequencies, is equal to the number of scores, or 20. Now, if we want to find out what the total sum of x is, and we can try to do this as best we can here, there's not a lot of room, but we take basically each score times the frequency and add those all up. So we would take 10 times 2 is 20. Oops. 9 times 4, 36. 8 times 3, 24. 7 times 3, 21. 6 times 3, 18. 5 times 3, 15. Hope I'm doing my times tables right here. 4 times 0, 0. 3 times 1, 3. 2 times 1, 2. And then we would add those up. Grab your calculator, because I'm not going to try to do it in my head. Add those all up, and they should give you the sum of all the scores. So rather than adding 3 plus 2 plus 6 plus 8, or plus 5 plus 5 plus 8 plus 7 plus 6 plus 9 plus 10, etc., especially if you have like 40 or 50 or 100 scores, you just simply multiply the score by the number of times it occurs and add all those up, and it gives you the sum of x, or the total number, or the total of all your scores added up together. So hopefully that clarifies the sum of the frequencies equals n. N is the number of scores, and the sum of x is calculated by multiplying x times f, or the value of the score, times the number of times it occurs in the frequency, and adding those values up. So go ahead and work that out. We'll check this in class, and I will see you next time. In class, we'll talk about how to group these into intervals, because that takes a little bit longer to talk about. But hopefully this is described to you what the purpose of a frequency distribution is, and a simple one anyway, and how you do it. It's pretty easy. So far, statistics aren't too bad yet, and they really won't get that bad. I will see you in class.